I'm Santiago Andrés Herrero. I'm the CEO of Genova Engineering Korea. English is not my mother tongue. I'll try to do my best, okay? Today, I would like to share some reflections on navigating maritime transformation in an increasingly fragmented world. We will look at geopolitical strategy, energy, and engineering factors reshaping our industry, identifying both challenges and opportunities. The maritime world stands as a crossroads. Global trade is expanding, uncertainty is rising, political fragmentations, energy transitions, and technological disruptions are reshaping every layer of our industry. According to UNCTAD 2024, nearly 80% of the global trade by volume moves by the sea. Okay? Highlights both the scale of our responsibility and the vulnerability of our systems. We are not only transporting goods, okay? We are also connecting economies, ensuring energy supplies, and enable industrial stability. When shipping stops, the world stops, that's true. My goal today is to explore how the maritime sector can adapt, lead, and innovate this fragmented world. I will share insights from Genova global perspective across Europe, Asia, and America, where we witness firsthand of how geopolitical tension, energy innovation, and engineering evolution intertwine. Let us begin by understanding who we are and how Genova has positioned itself within this transformation. Regarding the main figures, let me just introduce a little bit the company for you to understand. Genova is a global engineering and consulting company with more than 1,000 professionals, 15 offices all over the world, and around 1.5 million of hours per engineering. 80% of our teams are engineers, okay? We combine European hesitate with Asian efficiency and Latin American adaptability, creating a network that delivers high-end engineering worldwide, okay? Our portfolio covers also defense and offshore energy and renewables and shipbuilding, industrial facilities, which give us a panoramic view of how transformation unfolds across sectors. Beyond the numbers, what defines our ability to adapt, whether working on ammonia FSRU conversions or methanol dual fuel retrofits here in Korea, or defense vessels in Spain, or also platforms, wind platforms in Brazil, our teams share the same philosophy. Engineering must create value and resilience. At Genova, we don't see engineering as a cost. We see as a strategic asset. The stronger and the most integrated your engineering capability is, the faster you can adapt to global disruption. This mindset guides how we navigate the challenges that are reshaping our industry today. Regarding here, you can see the global map of our offices all over the world. It's quite easy to understand which one are our strengths. So we have offices all over the world. We can work 24 hours designing non-stop. I think that not many companies can do this, all right? Rather than that, and also because I'm here leading this office in Korea, and I'm the only one not Korean here in the office, okay? I would like to say that here in the office we have 30 engineers and 45 indirect engineers, okay? With more than 130,000 hours. We've been working on a very special projects, okay? Like a LCO2 carrier with lattice tank designs, or ammonia FSRU conversions, or methanol dual fuel retrofits. So with the same philosophy, engineering must create value and resilience. Now let's go to the aim of the presentation, okay? This is a sector under pressure. The maritime sector is facing unprecedented pressure. For decades, we operate in a globalized market. Today, that foundation is shifting. Geopolitical conflicts from the US to China rivalry and also the war in Ukraine, the tensions in the Middle East have reshaped shipping routes, insurance costs, and even types of vessels demanded. At the same time, this environmental and regulation pressure is intensifying. Under the IMO 2030 and IMO 2050 targets, our industry must achieve 40% reduction of carbon intensity in 2030 and also net zero in 2050. So these are not optional goals. So they define the new competitive landscape. Energy transition is another powerful force. We move toward alternative fuels, LNG, methanol, ammonia, hydrogen. That requires a massive redesign of ships, ports, also supply chains. Finally, fragmentation is not just political, it's structural. Value chains are decentralizing, supply dependencies are shifting of global to regional. In this environment, agility and collaboration becomes survival skills. The winners of tomorrow will not be the largest company, but the most adaptive ones, for sure. In this next section, we will examine how the geopolitics is rewriting the map of the maritime trade and what that means for the engineering and strategy. Geopolitical shifts and trade flows. So from the geopolitics today acts as both disruptor and catalyst of maritime transformation. Power dynamics between the US and China have made Asia epicenter of the global shipbuilding. 47% of all container ships orders in 2024 were placed in Chinese shipyards. This is a Clarkson research. In Europe, the Ukrainian conflict has redefined energy routes. Floating LNG terminals, FSRUs, and LNG carriers have become vital for replacing Russian gas imports, shifting the balance of maritime demands towards energy logistics. In the meantime, the Middle East remains a volatile corridor. Attacks the Red Sea and instability in the Straits of Hormuz have driven freight rate increase from 25 to 40% between Asia and Europe. There are some key choke points, like Suez, Panama, and Malacca, are now strategic pressure valves. A exclusion of any of them reverberates across the entire global economy. Okay? In this condition, push companies to rethink routes, strategies, and build redundant into the fleets. Flexibility is not size. It's now defining competitive advantage. As engineers and strategics, we must integrate geopolitical risk into our technical designs. Vessels must be adaptable to multiple markets, regulation, and also cargo profiles. The next logical question is, how does this volatility affect logistics and the supply chains that support global trade? Very interesting question. In this case, the impact of the logistic chains, so is based on the global supply chain, has entered a phase of structural recalibration. Efficiency is not longer the sole priority. Resilience is not the equally critical. Events like the Suez Canal blockade in 2021 or the Panama Canal drought in 2024 showed how vulnerable just-in-time systems are. Okay? A single choke point failure can freeze billions of dollars of trade in a matter of hours. So as a result, the companies are adopting multiple routes, logistic strategies, developing alternative corridors and regional hubs to distribute the risk. Meantime, engineering now are playing a major role in a shift port infrastructure. Ship design, fuel logistics must all involve support this more flexible network. Automation, real-time tracking, and also digital twins allows operations to anticipate disruptions and reroute dynamically, a crucial capacity in a world where geopolitical and climate risks are rising. What we are witnessing is a reorganization and globalization, so a more fragmented multipolar trade system where the maritime sector becomes the bridge connecting semi-independent regions. This transformation directly links the next major driver of change, the global energy transition. Talking about the energy transition in the maritime industry accounts for about 3% of the global CO2 emissions. This is coming from the UNCTAD 2024. Okay? And drive toward decarbonization is reshaping ship design, fuel infrastructure, and investment strategies. LNG has become a bridge fuel, representing 36% of the current global portfolio. This is coming from DNV 2024. While it is not the final solution, it's providing a traditional pathway towards the lower emissions. Methanol is gaining traction with companies like Maersk that already ordered more than 25 methanol fuel vessels, signaling a strong market shift. Ammonia and hydrogen remains in early stage with pioneer projects in Asia and Europe. Their success will depend, obviously, on global safety standard and scalable production. Beyond fuels, the offshore wind sector is booming. At least that's what all of us think. The Global Wind Energy Council projects 680 gigabytes of installed offshore wind capacity by 2035. A massive engineering challenge is requiring hundreds of specialized vessels. The key challenge is balancing economy, feasibility, regulatory, and compliance, even with the technological readinesses. Its fuels energy source will find the niche, but not a single solution will dominate. The shipbuilding nations that integrate sustainability and efficiency will lead the next maritime revolution. Regarding the shipbuilding industry outlook, here as we see that the shipbuilding is more concentrated today than ever. China, South Korea, and Japan account 81% of the global ships ordered. This is coming from Clarkson's 2024. This triad shapes innovation, prices, and fleet renewal. Korea obviously continues leading the LNG carriers and FSRUs, where its engineering precision and also cryogenic technology are world-class. Congratulations. China dominates the container bulk carrier market, benefit from scale and governmental backship financing. Japan has carved out a niche in a dual fuel, ammonia-ready, and also eco-design vessels, leveraging decades of research and development in the materials and propulsion. Emerging players like Vietnam and India are rising fast, very, very, very fast, especially in the mid-size cargo vessel and also in green vessel segments. This concentration reflects both opportunity and also vulnerability. While it drives specialization, it also expands to industry to regional stocks. The winners will be those who combine cost competitiveness with innovation and sustainability, building vessels that can meet the future regulatory and also market shifts. Regarding the engineering future, the role of the engineering is evolving from execution to strategy. Today, engineering defines competitiveness. Digital twins and advanced simulation reduce the integration in time by 15%, enable real-time testing of designs before the physical construction. Conversions, such as turning LNG carriers to FSRUs, save 30 to 40% of the capex, okay? Providing that smart engineering can outperform traditional invest cycles. New materials like new composites and structural adhesives are also reducing the vessel weight up to 20%, involving fuel efficiency and also lowering emissions. Engineering teams are now at the intersection of the data science, materials research, and operations, a multidisciplinary approach that redefines it means to design a ship. The more concerned the engineering ecosystem becomes, the faster innovation spreads. Collaboration platforms with AI-assisted design tools are the next frontier. In short, engineering is no longer a support function. Really, engineering is a strategic enabler of transformation. Regarding the oil and offshore oil and gas, still really relevant. While the world moves toward renewables, offshore oil and gas remain vital for global energy security. According to DNV and IAA data, fossil fuels will still represent over 50% of the global energy supply by 2040, even under accelerated transition scenarios. That means that oil and gas infrastructure will continue to demand high-performance vessels and engineering support, particularly in maintenance and also retrofitting and also digital monitoring. Many of the technologies are developed from renewables, robotic automation, EA inspection, organizing in offshore oil and gas. The knowledge transfer between sectors is a strength, not a contradiction. The challenge is to make coexistence responsibility, maintaining production efficiency while minimizing environmental footprints are preparing for a gradual decarbonization. Offshore oil and gas remain part of the transition, not outside of it. Regarding the offshore wind and renewables, so offshore wind market is entering in a phase of exponential growth. Okay? More than 200 CSOVs and SOVs vessels will be required globally over the next decade, okay, to support installation and maintenance. Floating wind technology alone could reach 20 gigabytes of installed capacity by 2035, okay, creating a new demand of specialized design and port infrastructure. Port readiness is a critical bottleneck. The most global ports lack the space and facilities to assemble and handle the next generation of wind structures. This is clear. Regional clusters in Europe, Asia, and the US are emerging as a backbone in this industrial expansion. Collaboration between governments, shipyards, and technology firms will be decisive. The offshore renewable ecosystems will require thousands of engineers, technicians, and specialized vessels, creating many opportunities for diversification across entire maritime value chain. This shift is not just environmental, it is economic. Offshore wind is becoming the new growth engine of maritime innovation. The challenges for the ship owners and yards as the maritime industry faces convergence of technical, regulatory, and human challenges that will define the next decade. Regulation is the first, the IMO 2030 goal, reducing carbon intensity by 40%, and the IMO 2015 target zero emissions, force the ship owners and yards to redesign business models and also not just ships, okay? Meeting these targets requires a heavy investment in research, new fuels, and also design innovation, often before the technology is fully mature or commercially deployed. Green financing mechanisms such as Poseidon principles are reshaping how the ships are funded. Financial instructions now assess carbon intensity as a part of the credit risk. Sustainability has become a condition for access to the capital. Beyond the technical financial aspects, there is a talent crisis. Lloyd Register in 2024 estimates a shortage of the to 20,000 naval engineers worldwide. This deficit threatens both capacity and innovation. In such an environment, so the success depends on collaboration between ship owners, shipyards, classification societies, and engineering firms. The real challenge is not just to comply with the regulations, but also to transform them in opportunities for differentiation and leadership. So regarding the innovation in shipyards, so the shipyards are clearly undergoing the most profound technological revolutions in their history. Automation and robotics are increasingly used in welding, cutting, inspection, improving pressure, safety, while reducing the human risk. EA supports predictive maintenance, design, optimization, turning massive data sets into operational insights, digitalization through to 3D design platforms, project integration tools, and also real-time simulation shortens condition cycles and reduce the errors. These technologies are not just efficiency tools. They redefine the competitiveness. The future shipyard will be smart, manufacturing environment, integrating human expertise, robotics, EA coordination, a place where engineers, machines, and algorithms collaborate seamlessly. Countries and companies that lead the digital transformation will control the place and the direction of the next industrial wave in shipbuilding. So the opportunities of collaboration in a fragmented world becomes the most strategy asset. The challenges we face, like decarbonization, digitalization, energy transition, are too complex for a single company or nation to solve alone. So you cannot do it alone. We need across the sector alliance between shipyards, technology companies, governments, and research centers. Europe and Asia are already pioneering joint research and development programs, creating clusters, accelerate innovations, share risk. Collaboration is not just about sharing resources. It's also about sharing vision, sharing trust, openness, and long-term commitment. This is very, very important, long-term commitment, okay? At Genova, so it's my company, so we see partnership as a multipliers of value. Our success story comes from collaborative projects where the multiple disciplines converge to achieve results that none could reach immediately. The maritime sector future will be defined not by competition, but by intelligent cooperation. Finally, almost finishing, so talent and training is very, very important. The greatest long-term risk for the maritime sector is not the technology, it's the people. The people, so I'm working all over the world, and I can feel, and I can talk with my colleagues, and all of them say that there is no people. This is clear, okay? We need to do something in respect, okay? The shortage of skilled engineers, naval architects, and technical specialists are already slowing innovation across the multiple markets. Future competitiveness depends on the investing in education and continuous training, from digital tools to sustainable design principles. Universities and industry must work together to modernize the curriculum and integrate simulation and foster multidisciplinary skills that combine engineering with data analytics, environmental science, and management. Equally important is attractive young generation. This is a real target. We must attract the younger generations. We must communicate that in this industry of innovation, global impact and sustainability, not traditional or declining sector. We are not a traditional sector anymore, okay? Diversity and inclusion are also key. The maritime industry can no longer afford to underuse half in this potential talent pool. Building the workforce of the future is not an option. It is the foundation of our long-term resilience. So, as a Genova position, so we are strategically positioned to navigate and lead through to this transformation. So we have extensive experience in LNG carriers, FSRUs, offshore wind, defense. So, but our global footprints span Europe, Asia, and America, and support more than 500 engineers. So we work side by side with the ship owners and shipyards, and from the earliest conceptual stage to plan approval, ensuring designs are both innovative and executable. Our goal is to be more than a supplier, is to be an strategic partner, capable of anticipating changes and guiding the client through to the uncertainty. In essence, we stand for resilience, flexibility, and innovation. These are three values that define the future of maritime engineering. So, as a closing message, today we have been seeing the maritime sector is not only under pressure. It's in the middle of a profound transformation. Yes, transformation creates complexity, but also sparks innovation. Every disruption forces to rethink, redesign, and reinvent. The future will not be led for those who resist the change. The future will be led by those who embrace it intelligently. The maritime industry is the heart of the global stability, but without it, energy, food, and goods simply don't move. That makes our responsibility and our opportunity enormous. At Genova, we believe that this innovation, talent, and collaboration, we can not only adapt to the future, but we can define it. Let's transform fragmentation into resilience, competition into cooperation, and pressure into progress. Yeah, thank you very much, and let's keep navigating this transformation together. Kansamida.